So I don't even know really where to begin, guys. I know it's been a while, but so much has happened. Made a few changes, just a few. We have a massive engine in this thing. It's driving so much better. It's actually probably just about perfect on power level now. So overall, a lot of improvements. So I'm going to go over some of them. So yeah, this Ninja 250 engine that's in here right now, I have set up with high flow air filters, high output exhaust, so I have it jetted properly for that level, so it's not running lean anymore. You can see an oil catch can here. Have it all set up electronics wise, it's running well. Stock radiator and stock fan are on there, and then I added this much larger fan because, you know, we're doing a lot more low speed stuff. We're not running at high speeds for long periods of time, and the radiator is not in the front anymore, so it's not getting quite as much airflow as it would normally. Now we're going to get into the topic of this video, which is putting an engine like this in a go-kart. I don't even know if I really want to call this thing a go-kart anymore. It's more of a dune buggy, sand rail kind of thing. It's gotten a little above the level of go-kart. But I'm going to go over what I did to this engine to allow it to go in here, the engine mounts, all the troubleshooting that I had to do to get this engine running properly, because it is difficult, wiring, stuff like that, everything that you need to get this engine into the go-kart and get it running. Okay, so first things first, how I actually got this thing mounted in here. There's 3 engine mount positions on the engine itself, one right there, one there, and one there. So 3 mounting points, and I decided to use all 3. I've seen people only use 2. It probably won't hurt it, but I decided to use all 3. So what I essentially made was a cradle. It goes from there, down, across, and up. So it's a separate unit, all made from flat stock, I think 3/16 inch thick steel, so it's certainly not going anywhere. And then that cradle sits on 4 feet. One there, there's one there, and then 2 on the other side. And those feet are pieces of channel steel. So they sit perfectly on the frame rails here. And what that allows it to do is the whole engine can slide back and forth a little bit. Now that's going to come into play later with your chain tensioning. It's a lot easier to do it that way than to have an external chain tensioner. I can actually slide the whole engine forward to tension the chain. Okay, so now that your engine's in, the next thing you're going to need to do is hook up your carburetors. This is what's going to allow your engine to run, and it's probably one of the most difficult things to do, only because there's such a complicated piece of equipment that a lot of things can go wrong. The most important thing, especially for CV carbs, I'm probably going to make another video about this to explain it all, but for now just know that there's a vacuum system in here that the engine sucks on the carburetors to bring the fuel and air in, as well as operate the throttle. So the seal between the engine and the carburetors needs to be really good. There's these rubber boots on here with a type of hose clamp. You really have to make sure that the seal on those is good. If there's any pinholes, you need to replace those boots immediately. Otherwise your engine won't run well. Next up, you can see there's a lot of hoses coming out of here. These 2 are part of the vacuum system in a part called the coasting enricher, which brings extra fuel into the engine when you're letting off the throttle to prevent the engine from backfiring and other things that can go wrong there. This hose is part of that as well. This one I have plugged. It's only there to cover up the port there on the left carburetor. Those ports are used for balancing the carburetors. That's very important. That'll be another video that I'll do. Fuel line here going from the gas tank into the fuel inlet on the side here, and then this red hosing is really not necessary, but I have there to cover up the fuel overflow port here. That's if you're engine, were to flip upside down or something, the fuel would flow through there. Normally it drains on a motorcycle. I have it just running up here and then down to the side here. It really doesn't go anywhere in particular. Next, you can see I have the choke cable set up here. I have a choke lever on my dash, as well as the throttle cable here. So that's pretty much all you need for your carburetors. Again, I'm going to go into a more detailed video at some point on cleaning them, doing things like that to get them up and running to allow your engine to run really well. But for now, we're going to move on to cooling. Cooling, something I had a bit of an issue with. It's pretty simple system. There's a radiator right here, a fan on the front and a fan on the back. The fan on the front I added to the stock setup to add a little extra airflow for low speed driving. You can find documents online that show diagrams of the cooling systems for these engines, but here's all you really need to know. There's an outlet here on the engine, on the top of the engine. There's a hose that runs thermostat. So engine to thermostat. The thermostat opens and closes to control the flow of the coolant through the system to cool down the engine or allow it to warm up. Next, you have another hose that runs to your radiator cap. This is what pressurizes your system. If it pressurizes it, I believe, to 15 psi, and that brings the boiling temperature of the coolant up so it can run properly and not boil off. That has an outlet port on it, so if the pressure exceeds 15 psi, the air and extra coolant can flow down into the coolant overflow tank, which you can see off to the side here, this red thing. That can just be a plastic bottle, really. I got something that looks fancy, but matches with the red scheme. Next, in the bottom of the radiator cap, you're going to have a hose that goes into the radiator itself. It's going to go into the top port on the radiator, flow through the radiator cooling fins, and out the bottom down here. From there, it's a straight shot from your hoses straight into the inlet port on the left side of the engine here. You'll see that's the tall metal hose that sticks up off the left side right over the stator cover area. It's not a bad idea when the engine's dry to take off the water pump and inspect the fins to make sure that they're not worn. You can get pitting and corrosion in there. So now I'm going to talk about coolant. Make sure you get the proper mix. I believe mine was 50-50 water and coolant. That's a good mix, for general. If it's really cold where you live, you want more coolant and less water. If it's really warm, you can get away with a little bit more water. So when you're at it, let's say you don't get a pre-mixed solution, which you should go with. It's just the easiest way. If you don't get a pre-mixed solution and you're going to add it yourself, make sure you use distilled water. You don't want water with any minerals in it or anything like that. So you want distilled water. That's very important, because that water in there, if it's not distilled, has little minerals, and they're going to eat away at the coolant passages, and you can get some corrosion and problems with your cooling system. That's very important. So next up is going to be wiring. This part wasn't too bad for me. I've heard kind of different opinions on that. A lot of people do have issues with it. But if you have a general idea of what you're doing, you can solder, you have a lot of wire available, and you have a general idea of how all these parts work, it's really not too bad. You can see here I have an old ammo box where I store all the extra wiring in there. I have zip tied the starting relay, the CDI box, the voltage regulators mounted on top here for airflow. So different things like that. You want to make it look pretty. This particular side isn't too good looking. I have wires that I haven't wrapped yet going up to the cooling system up there. You can see my fan wiring here, starter motor, all stuff like that. There's a lot of different sensors on this engine. You can see an oil pressure sensor here, water temperature sensor up on the radiator. So different things like that. You want to keep an eye on. There's ways you can check that. If you look up on YouTube, checking those sensors and stuff is not a bad idea before you even get your engine mounted. So if I were to open this up, you'd see the CDI, starting relay, all the other relays associated with the engine. I've essentially bundled together all the lighting wiring so that I can use it later. I don't have any lights on here now, but I plan to add some in the future, so if I can tie those right into the stock setup, I can use stock switches and stuff like that, and it'll all be really clean. So when you have all your stuff mounted in the box together, you get all your wiring set up, there's a couple specific switches that you have to look out for, particularly with this engine. With other engines, there's similar switches and maybe some additional ones as well. The first thing is your neutral safety switch. On this engine, it plugs in right here above the sprocket. If you had a cover on there, you probably wouldn't be able to see it, but it's just a bullet connector, and that tells the wiring system when the bike is in neutral, or when the engine's in neutral. That's important because the engine will not start if the bike is not in neutral. This engine doesn't have a clutch safety switch, so there's no way to start the bike unless it's in neutral. Another troubleshooting thing to look out for is if that connector comes loose, you won't be able to start your engine either, even if it is in neutral. And an easy way to check that is up on the dash. There's a neutral indicator. The other most important switch for me, because I did forget about this when I was initially trying to start it, was the kickstand safety switch. On a motorcycle, for obvious reasons, they don't want you to go into gear with the kickstand down. So you'll be able to start the engine with no problem, but as soon as you try to put it into first gear, it'll cut out. So I had this issue. I was going to drive it for the first time. I put it in first gear and it would die electrically. I could tell it wasn't an issue with the clutch or anything because it would die like electrically. Well, it turns out I had deactivated the wrong switch essentially. I don't know what two wires I had connected to each other, but they weren't the kickstand switch. So it took me a while, but I used wiring diagrams, located the two wires that were connected to the kickstand switch, and essentially just connected them together to trick the engine into thinking that the switch was closed permanently. So that solved that issue, and now the engine's running really well. You're really going to want to take some time to think about the routing of all your wiring. There's a lot of wires that go to both the start switch, the key switch, as well as the dashboard if you're using one of the gauges. You can see it all comes out of this cutout that I put in here, as well as one in the back and one in the front. And then all the wiring gets neatened up and put into conduit that I have zip tied to the frame and running up very nicely to the different locations where it needs to be placed. You can see I have the conduit running along the frame rail here, up the frame support there, and then behind to the back of the dash where it's all bundled up nicely. Eventually I'm going to put some sheet metal to make my dashboard here, and this will all be covered up. You can see the key switch over here, as well as three switches. I have one to bypass the fuel gauge. This isn't really necessary, but I thought I'd rather look at the full fuel gauge rather than the empty one. So you can see when I flip that, the fuel gauge goes up. These two switches do have purposes. This one on the left is the stock cooling fan, and this one is the auxiliary cooling fan that I added. So I flip those on as I drive more and more to prevent the engine from overheating, as well as the current fan. The stock one has a switch on the radiator that turns it on automatically when the engine reaches a certain temperature. Connecting a throttle cable to these engines is fairly straightforward. You can see the throttle linkage here. Just a normal barrel end throttle cable mounts right here, and then I have that running forward down the frame, actually to a connector here, so I can hook together two cables, and then forward all the way the rest to the accelerator pedal there. So you can see how I have that mounted up so that there's a spring loaded here, and then the cable sits right in there. Clutch uses a similar system. I used the heavy duty brake cable from GoPowersports.com to run that forward, similarly to the clutch pedal all the way to the left there. The brakes are hydraulic, so that's fairly straightforward. I have a video out already explaining my hydraulic brake system, so you can go check that out and see how I routed that. Control you're going to have to hook up is your shifting. I have that through this lever right here. You can see it runs down to a base here, and then there's an arm coming off of it which goes back here to this bearing, which is a piece of 5/8 inch steel that runs to the other side of the frame with 2 tabs coming off of it. That way, when I push forward to shift up, it rotates that shaft, moving the lever on the other side to then pull on the shift spline on the other side. I'll bring it around to the other side to show you that. It is difficult to see down there, but you're looking at a heim joint that is connected to the tab coming off of that piece of 5/8 inch steel. You can see there is a bearing down there that's bolted to the frame. Off of this lever, that heim joint has a steel rod that goes down to another lever that is then connected to the shift spline coming off the engine. You can mess around with the height of these bolting positions. I have a few holes drilled so I can mess with that to adjust the throw of the lever to shift between gears. I prefer mine to be fairly stiff and a short throw. You can adjust that depending on your setup to get the proper shift throw. Okay, so now that I'm in the cart, I can show you the basics of my system and how it works regarding starting the engine and then driving. So, normal stock key switch here. Turn that, turns on the gauges. You can see the neutral light comes on here. That tells you when you're in neutral. It's very important when you're driving, obviously, because when you're coming to a stop, you can throw it in neutral, as well as if you stall, you have to get the bike back into neutral before you can start the engine back up again. Down here on the shift lever, I have the stock kill switch and starter button here. So when I'm ready to start the engine cold, I have a choke lever here, which I can turn down to activate the choke, push up to deactivate it. Right now it's all warmed up, so I'm going to leave the choke off. Next, I'm going to go ahead and press the button and start the engine. See, it starts right up. The engine idles well. You can see it was a little bit cold there, so it wasn't quite revving as well as normal. But yeah, this engine revs all the way up to 13,000 RPM at redline, which is plenty for me. Gets most of its power, I'd say, above 7,000. So when you're driving, if you want to be more fuel efficient, stay around 5 or 6. But if you want to, get it going, you definitely want to be up above 7. So overall, it's a ton of fun. Stay tuned. I'm going to make a lot more videos now that I have a lot of time with this coronavirus going around, to go over specific parts of the setup, how they work, and obviously I'll be adding some things to this to finish up the project. Eventually I'm going to add body panels, the rest of the floor pan, as well as some more switches and lights as well. So yeah, stay tuned for that. Thanks for watching, and I hope this helps you out. If you have any specific questions or things you want to see, say like, oh, I want to know how your suspension works, or I want to see your chain drive system, just go ahead and comment that below and I'll be sure to cover it. I'm looking for video suggestions right now because I have so much extra free time. So yeah, I look forward to hearing from you guys, and thanks so much for watching.